In this video, we vary the wavelength of the Moivre sine function over the values of W from 5 to 6. So data validation, list of items 5 to 6. We can start with 5. And the Moivres in the form of the Taylor series, summation of a times x to the power n, where the value of n is from 0 to infinity, and the value of a is the coefficient, which is the Moivre in the form of the Moivre. That is the imaginary part of 0 plus wi raised to the power n. So that's the complex number raised to the power n. Begin with the de Moivre's complex number. So array formula. Complex. 0 plus wi. So 0, comma, w. That's the complex part. And this is raised to the power n, where this is the de Moivre's formula. So IMPOWER of a complex number to n. And we want the imaginary part, so this will be imaginary. That's the part that we want. And we continue. After the imaginary part, we divide by factorial of n. So divided by factorial of n. Now we can complete the Taylor series expansion. So array formula of the x values raised to the power n, where n starts from 0, incremented by 1. That's series sum. So array formula series sum. So that is array formula series sum of the x values raised to the power n, where n starts from 0, incremented by 1, and the coefficient will be this range. Now we can continue with the Taylor series expansion using the cotangent equivalent. So this will be sine of x raised to the power w times the summation of combine x w comma n times sine wn minus w minus n times pi over 2 times cotangent x raised to the power n. That is with this letter b, or b coefficient, which is the combination and the sine function. And the value of n is from 0 to w. So we begin with the array formula. COMBIN. That's COMBIN w comma n. W comma n. That's the first part. Second part, this is sine w minus n pi over 2. So this will be sine 0.5 pi. Sine 0.5 pi. .5 pi times the quantity w minus n. So we have the first part, the combination, and the sine function. And we correct this. If this is, because our limit of w is from 0 to w, or n is from 0 to w, so we correct this. So if n is greater than w, n is greater than w, then 0, otherwise calculate. Now it's corrected. We continue with the expansion, which is array formula series sum of the x. This is cotangent x, so cotangent x raised to the power n. cotangent x raised to the power n, where n starts from 0 incremented by 1, and the coefficient will be this range. And we continue. This will be multiplied by sine x raised to the power w. So, but there is an error, so we have to correct that error. Since it's sine x equals 0, it should be 0. So correct this. If x equals 0, it's 0. Otherwise, calculate. Now it's corrected. We'll chart this. Before we chart this, we have to correct this. There is a missing part, which is sine x raised to the power w. So we multiply that to the series sum. Sine of x raised to the power w. Now they're the same. And we chart this. Insert chart. And we use scatter chart. You don't need the title, but we need to correct this. Use column as label. And for the series, show the trend line. The type polynomial. The degree 10. For the label, use the equation. And here's a trend line and polynomial. You can increase the W to 6. So the wavelength now is shortened. We also changed W here to 6. Change the wavelength of the Moivres, changing to 7. We can also change the equivalent, the cotangent formula, to 7. Change this to 8. And we shorten the wavelength to 8. So this completes the use of the series sum function, cotangent, sine combination, and the Moivre sine formula to generate change the wavelength of the Moivre sine function.